This just in on really fake news. The ocean's motion now makes sense, and RFN has all the details.
Yes, Corey, this is what is being called the biggest oceanographic news since Nansen put down the bottle. Scientists have discovered thermohaline circulation.
Let's begin this breakdown at the top. What does thermohaline mean?
Good question. Thermo, of course, means heat or temperature.
Like a thermometer.
Sure. And haline is derived from halos, meaning salt.
So putting two and two together, thermohaline circulation is circulation about heat and salt differences.
The temperature and salinity of a water mass affects its density, and the density differences cause motion. You could say that density is the driver of thermohaline circulation.
Really? I thought density drove the bus.
Nope, that's Denise. Anyways, water that is warm is less dense than water that is cold, while the low salinity water is less dense than water with a high salt concentration.
Interesting, but what causes the water to have different temperatures and salinities that change the density?
Well, it's actually rather simple. Water becomes light when it is exposed to things like heating from the sun, river runoff, rain, and icebergs melting. These processes cause the water to warm up and become less saline.
It's raining men, hallelujah, it's raining men. I'm sorry, all I heard was rain, and what makes water heavier?
Okay then. Ocean water is made heavier by evaporation, cooling by the air, and Brine rejection, which is freezing of the ocean water that leaves salt behind. The x-axis represents salinity and the y-axis represents temperature. The black contour lines are different densities. As you can see, different combinations of salinity and temperature can create the same density. The blue S-shaped line is the ocean's density, with depths marked along the way.
I like the use of blue in this picture. It gives an exciting feel to a rather dry topic.
Moving along with the explanation.
Yes, so now that we understand density, in what manner does the circulation circulate?
Well, thermohaline circulation creates something the scientists like to call the global conveyor belt.
I prefer a black leather belt myself, but to each their own.
This isn't a fashion belt. This belt helps circulate warm and cold water to different parts of the world in deep ocean currents. One circuit can take thousands of years.
Oh, no wonder it took him so long to figure it out.
Yep, it's taken 30 years to figure out deep ocean currents.
Wow, that's incredible. How exactly does the belt thing work, though?
Well, there isn't really a starting point, but for ease of explanation, we'll say it starts at the equator, where the water is heated by the sun and flows north towards the poles in narrow surface currents as it cools. Once it reaches the poles, the water is much cooler than it was at the equator, sinks, and continues to flow all around the world.
Does anything else play a role in the circulation?
Yes, in fact, fresh water that comes in from the melting of the poles pushes the salty water coming in from the equator farther into the ocean.
Anyways. Wonderful! What type of effect would thermohaline circulation have on the big blue?
Well, there are two main effects of THC. One is the movement of different water masses, and the other is the creation of regions of upwelling.
I thought THC made you feel euphoric and forgetful.
THC is thermohaline circulation in this case.
Gotcha. So, what is a water mass?
Well, there are areas of water that have similar temperature and salinity profiles that also travel in the same manner.
Oh, so what's an example of a water mass?
Well, we have Antarctic bottom water and North Atlantic deep water, just to name a couple.
And what characteristics separate these two water masses?
Well, Antarctic bottom water is known for being the densest water in the world.
Just like I'm the densest news reporter in the world.
Different kind of dense, but yes, still very true. One reason that the Antarctic bottom water is so dense, besides being cold because it's at the poles, is a major component of Brine rejection. 20 to 50 million cubic meters of brine are dumped into the Antarctic water mass every second.
Salty. So where does all this water mass go?
Well, it begins near the Antarctic coast of South America, and then, as it mixes with the Antarctic circumpolar current, it descends along the continental shelf where it flows along the deep sea beds.
Now what about the North Atlantic deep water?
The North Atlantic deep water is formed in the Arctic Ocean outflow and the submarine ridges between Scotland, Greenland, and Iceland. The warm water going towards the poles runs into the winds near Canada, which cools it down. The heat released into the air during cooling is why countries like England and Ireland have such temperate climates so far north.
Anything else we should know about the water masses before we discuss upwelling?
Yes, when it comes to sinking water masses, the colder the water, the faster it moves. Also, the water masses don't mix well together, so they end up forming areas known as convergence zones, where the heavier water can slide under the lighter water.
Brilliant! Now tell me about upwelling.
Certainly. Upwelling is when less dense, nutrient-filled water rises from deeper regions to more shallow regions. This is a side effect of thermohaline circulation because, as we saw in the idealized model, there is a sinking of cool water, which means it must be replaced with the rising of warm water. In fact, upwelling due to thermohaline circulation is how low to mid-low latitudes have a steady thermocline.
What is a thermocline?
A thermocline is the area where the temperature changes most rapidly in the ocean. THC moves quite slow, with upward movement of about 1 centimeter per day in upwelling regions. But if the upward movement were to stop, the thermocline would drop in ocean depth, so you could say the thermocline is essentially held up by the slow upward movement of the THC.
Wow, it sounds like a lot of stuff happens really slowly in the oceans.
Kind of. The average cycle of deep ocean water is 200 to 300 years, and in extreme cases, like the Antarctic bottom water, the water can remain in the water mass for up to 1,600 years. There are areas of rapid movement, however, which can be seen as ripples on the ocean floor.
What causes the currents to flow faster in these areas?
Well, these contour currents are usually due to water having to flow around seafloor obstacles.
All of this seems fine and dandy, but why should an average Joe like me care about thermohaline circulation?
Well, do you like the climate we live in?
Of course I do.
Well, you have thermohaline circulation in part to thank for that. It helps regulate the Earth's climate by moving heat and energy around the globe.
Well, thank you, THC, then.
Indeed. And that's all there is for this really fake news breaking report.
We will now return you to your regularly scheduled program of Watching the Grass Grow.